In the C programming language, operations can be performed on a bit level using bitewise operators. Bitewise operations are contrasted by byte-level operations which characterize the bitewise operator's logical counterparts, the AND, OR and NOT operators. Instead of performing on individual bits, these operators perform on strings of 8 bits at a time. The reason for this is that a byte is normally the smallest unit of addressable memory. This applies to bitewise operators as well, which means that even though they operate on only 1 bit at a time, they cannot accept anything smaller than a byte as their input. Bitewise operators, C provides 6 operators for bit manipulation. Bitewise and ampersand. The bitewise AND operator is a single ampersand, and it is just a representation of AND which does its work on the bits of the operands rather than the truth value of the operands. Bitewise binary AND does the logical AND of the bits in each position of a number in its binary form. For instance, working with a byte 11,001,110 and 10,011,000 equals 10,001,000. The most significant bit of the first number is 1 and that of the second number is also 1, so the most significant bit of the result is 1. In the second most significant bit, the bit of second number is 0, so we have the result as 0. Bitewise OR vertical bar, similar to bitewise AND, bitewise OR only operates at the bit level. Its result is a 1 if one of the either bits is 1 and 0 only when both bits are 0. Its symbol is vertical bar, which can be called a pipe. 11,001,110, 10,011,000 equals 11,011,110. Bitewise XOR hat. The bitewise XOR performs a logical XOR function, equivalent to adding 2 bits, discarding the carry. The result is 0 only when we have 2 zeros or 1s to perform on. XOR can be used to toggle the bits between 1 and 0. Thus, I equals I1 when used in a loop toggles its values between 1 and 0. Bitewise not ~1's complement, the 1's complement or the bitewise complement gets us the complement of a given number. Thus we get the bits inverted. For every bit 1 the result is bit 0 and conversely for every bit 0 we have a bit 1. This operation should not be confused with logical negation ! Summary of bitewise operators. Shift operators. There are 2 bitewise shift operators. They are, right shift, left shift, right shift. The symbol of right shift operator is. For its operation, it requires 2 operands. It shifts each bit in its left operand to the right. The number following the operator decides the number of places the bits are shifted. Thus by doing ch3 all the bits will be shifted to the right by 3 places and so on. Example, if the variable ch contains the bit pattern 11,100,101, then ch1 will produce the result 01110010, and ch2 will produce 00111001. Here blank spaces are generated simultaneously on the left when the bits are shifted to the right. When performed on an unsigned type, the operation performed is a logical shift, causing the blanks to be filled by zeros. When performed on a signed type, an arithmetic shift is performed, causing the blank to be filled with the signed bit of the left operand. Right shift can be used to divide a bit pattern by 2 as shown. I equals 14. Bit pattern 1110, J equals I1. Here we have the bit pattern shifted by 1, thus we get 111 equals 7, which is 14/2. Right shift operator usage. Typical usage of a right shift operator in C can be seen from the following code. Example. The output of the above program will be. The decimal 5225 is equal to a binary, 0001010010101, 5225 right shift 0 gives 0001010010101, 5225 right shift 1 gives 0001010010100. 5225 right shift 2 gives 0001010010110. 5225 right shift 3 gives 0001010010101. 5225 right shift 4 gives 0001010010110. 5225 right shift 5 gives 0001010010011. Left shift. The symbol of left shift operator is. It shifts each bit in its left-hand operand to the left by the number of positions indicated by the right-hand operand. It works opposite to that of right shift operator. Thus by doing ch1 in the above example we have 11,001,010. Blank spaces generated are filled up by zeros as above. Left shift can be used to multiply an integer in multiples of 2 as in int I equals 4. /bit pattern equivalent is 100 / int j equals I2. / makes it 10,000 a multiple of 2 that is 16 /. A simple addition program, the following program adds 2 operands using AND, XOR and left shift. Byte-wise assignment operators, C provides a compound assignment operator for each binary arithmetic and byte-wise operation. Each of the compound byte-wise assignment operators perform the appropriate binary operation and store the result in the left operand. The byte-wise assignment operators are as follows: logical equivalents. 4 of the byte-wise operators have equivalent logical operators. They are equivalent in that they have the same truth tables. However, logical operators treat each operand as having only one value, either true or false, rather than treating each bit of an operand as an independent value. Logical operators consider 0 false and any non-zero value true. Another difference is that logical operators perform short-circuit evaluation. The table below matches equivalent operators and shows A and B as operands of the operators. Equals has the same truth table as but unlike the true logical operators, by itself. Equals is not strictly speaking a logical operator. This is because a logical operator must treat any non-zero value the same. To be used as a logical operator, equals requires that operands be normalized first. A logical not applied to both operands 1 unregistered trademark T change the truth table that results but will ensure all non-zero values are converted to the same value before comparison. This works because on a 0 always results in a 1 and on any non-zero value always results in a 0. The example below shows that the truth tables for these byte-wise and logical operators are identical but also demonstrates how they act on their operands differently. The need to normalize operands for equals can be demonstrated by introducing a char T2 equals 0x02 and packing it in an array. Mixing T2 with T will show them being treated the same unless the operand not surround equals are removed. Example: the output of the above program will be byte-wise and passed was 8 expected 8, byte-wise OR passed was E expected E. Byte-wise XOR passed was 6 expected 6, byte-wise not passed was FE expected FE. Logical and passed was 1 expected 1, logical and passed was 0 expected 0, logical and passed was 0 expected 0, logical and passed was 0 expected 0. Logical OR passed was 1 expected 1, logical OR passed was 1 expected 1, logical OR passed was 1 expected 1, logical OR passed was 0 expected 0. Logical XOR passed was 0 expected 0, logical XOR passed was 1 expected 1, logical XOR passed was 1 expected 1, logical XOR passed was 0 expected 0. Logical not passed was 1 expected 1, logical not passed was 0 expected 0. See also bit manipulation, byte-wise operation, operators in C and C++, bitboard, Boolean algebra, XOR swap algorithm, XOR linked list. References. External links, byte-wise operators.